All right, so yesterday we were given polynomial functions in factored form. We were able to find the zeros of those functions. Now we're going to work the other direction. So if you need to recover yesterday's lesson, go back to October 10th, watch zeros of polynomials first. So for the first example we're going to do, I'm going to specify zeros at x equals -3 and x equals 1. And what we learned about these zeros yesterday was that they have the opposite sign of what the factors are in the function. So watch how we can write a function in factored form based on this. We'll have x plus 3 times x minus 1. It's as simple as that. We take the sign of the zero and we flip it when we rewrite that in factored form. Now, if you can pull up Desmos, I highly recommend plotting this on the graph so we can make the connection between graph and function. But understand if we're catching up and we're short on time and we cannot necessarily do that. Let's see how this plays out in another example. All right, I'm going to have zeros at x equals -4, x equals -2, and x equals 1. Now, if you think you already know what's going on, pause the screen, try this on your own. Otherwise, check this out. Our first factor will be x plus 4. We simply flip that sign. Next factor will be x plus 2. And our final factor will be x minus 1. Let's do one more example here. Again, pause the screen after the zeros if you want to try this on your own first. We'll have zeros at x equals -3, x equals -1, x equals 0, and x equals 2. Okay, our factored form will look like x plus 3, flipping that sign, x plus 1, x minus 0, and I'm going to come back to this one in a second, and x minus 2. Now, that x minus 0 portion, if we want to, we can simply rewrite that as x, because that, anything minus or plus 0 is going to be itself. And we can rewrite that function in a shorter hand if we wanted to with x plus 3, x plus 1 times x minus 2. The other thing that we're going to see today is this idea of multiplicity, and this is how many times a given zero or root shows up in a function. So go ahead, pause the screen, copy this definition down into our notes, as well as this example below. We'll see in this example here that we have three different factors. All right, we have x plus 3, and x minus 2. And if I calculated the zeros for each of those, I would get x equals -3, x equals -3, and x equals 2. Okay? This x equals -3, that shows up twice. So we can say that this has a multiplicity. I have a difficult time writing this out on my touch screen, of 2. Shows up twice, so it has a multiplicity of 2. Meanwhile, the 0 x equals 2 has a multiplicity of 1. Okay, we're simply figuring out how many times that shows up. Now, we can do the same thing we were doing before, building functions, using this concept of multiplicity. So let's see how this plays out in example 4 here. If I have a 0 at -3, and it has a multiplicity of 2, then I also have a 0 at 2. Sorry, I should write this x equals 2, x equals -3. And that second 0 has a multiplicity of 1, then my function is going to look like this. We'll have x plus 3 times x plus 3 times x minus 2. Okay, let's see how this plays out in a couple of other examples. If we have a 0 at x equals 4 with a multiplicity of 2, okay, then my function will look like this. X minus 4 times x minus 4. Another way to potentially rewrite this Another way to write this, if we wanted to write it a little more shorthand, is we have a factor times itself. We could write this as x minus 4 to the second power if we wanted to, because that multiplies by itself once. Just a quick side comment there. And for our final example, let's go with this. We have a 0 at x equals -1 with a multiplicity of 2. We have 0 at x equals 1 with a multiplicity of 1. And a 0 at x equals 2 with a multiplicity of 1. Okay, we can write this function, and I'm going to write it just a little below here so I have more space. Y equals x plus 1 times x plus 1 times x minus 1 times x minus 2. And again, if you wanted to shorthand that factor that has the multiplicity, we can write it as x plus 1 squared times x minus 1 times x minus 2. Either option is correct, but just a different way of writing this shorthand.